Good afternoon. This is Jason Ozols with RCR Wireless News. Welcome to today's webinar presented by F5, Evolving to the Application Delivery Network. Our presenter today is Sean Duggan, Director of Product Management and Marketing at F5. Now, before I hand this off to Sean, I'd like to cover a few admin items with you all. Within 24 hours, all attendees and registrants will receive a link to the recorded on-demand version of this webinar. You're encouraged to submit questions throughout the presentation. Sean will address and answer these questions near the tail end of the webinar. We will also be launching 2 live polls during the broadcast. Now, at this point, I'd like to introduce our speaker, Sean Duggan, Director of Product Management and Marketing at F5. Sean, take it away.
Thanks, Jason, and thank you everyone for attending today. I appreciate this opportunity to discuss about the changing landscape in service operators and how they are moving towards and evolving towards an application delivery network. To start off, just kind of want to go back in history a bit and kind of cover how service operators built out their networks and monetized their networks over the course of the last few decades. So as we all know, the operators started deploying physical wire, and just deploying that wire, or in the mobile space, that the radio wireless connectivity, that in its own right was the value which they were monetizing. They were connecting people into voice services, connecting people to each other for voice, or fixed line data services, point-to-point data services. As the physical plant got more ubiquitous, they moved into virtualizing that with technologies such as, after X.25, frame relay, ATM, and eventually Ethernet out into the properties. And at this point, it was still working to help monetize their value, provide multiple services over a physical plant, and deliver those types of data services along with their voice services. Next came really the IP revolution and internet connectivity. So as service operators and customers wanted to connect onto the internet, the service providers were able to monetize that by providing IP connectivity into the internet and IP connectivity from site to site as well. But as we all know, IP has now become part of the infrastructure of where mobile and fixed operators are going. So to monetize IP, really what operators are looking towards and where they need to move towards is being able to monetize those services that layer on top of the internet protocol. As voice services continue to decrease, as over-the-top services such as video, chat, voice continue to increase from other providers, service operators are faced with this challenge of really looking towards implementing an application-style delivery network or a service delivery network that helps them have layer 4 through 7 awareness and be able to help monetize those services and provide new, unique offerings to their customers. So when we look today with operators really focusing still on connectivity, and that connectivity, as we just discussed, is anywhere from a physical to a wireless base, with being able to provide data and voice services on top. Mobile operators in particular need to have a paradigm shift. And part of this is really moving from that connectivity to providing an experience. As you see the shift in device access, folks accessing the internet, their corporate resources from a host of different devices, most of them now wireless, that connectivity not only is a key fundamental component, but for a differentiator, it's providing that experience to those users, how they can manage their services in a wireless fashion, and new connectivity from healthcare, for example, offering physicians mobile access with their iPads, their iPhones, back into their healthcare systems. But on the infrastructure side, the operators also have to shift their paradigm on how they look at their network infrastructure as well. Well, starting with that network infrastructure, if we see the evolution of these operators and where they've moved from is, they've had their siloed infrastructures in the past, where you started with your mobile infrastructure, your voice network, your data network, and even fiber network. And all those networks covered their own access, their own transport, their own control, and their own set of services. Today, we've seen a collapse of a lot of those. While the physical plant still exists, what a lot of operators have moved towards is a common transport layer, with IP being that common transport. They've also introduced control across multiple aspects of these networks, such as IMS. And they're offering services such as IPTV, data connectivity, chat type services across all four of these types of different offerings or networks, and looking to further consolidate this to provide a ubiquitous flow for their end users as they can move services from one device to another device. And as they look to offer those types of services, of course, the network needs to change again. And this is where we see the recent trends with software-defined networking and really the network function virtualization effort that many operators are looking to implement. And what this does is it further abstracts the physical plant, be it wireless or wireline, into a cloud-type infrastructure where they move things into large capacity data centers. They provide connectivity back to these data centers, and they introduce such technologies as virtualization into these. What this requires, of course, is also a change of how they evolve their organizations and their networks to deal with a tier of infrastructure upon which services run on top of as a cloud-type function. Of course, all of these efforts, moving towards the application delivery network and the cloudification of their networks, really are there to try to address the growing trend where traffic continues to increase, revenue is flattening, and the services shift is moving from a voice dominant type service offering into the data dominant type offering. And so these efforts and where the operators are looking to go and where they need to look to go is to change that infrastructure and look for new offerings and services that they can provide to their subscribers to help close these gaps. So what are the business drivers, and where do these operators need to move for? Well, operators sit in the middle of a host of different capabilities that they can provide in connectivity. They have awareness of users from a residential to an enterprise to commercial entities. They need that awareness of the different types of applications and services that they're offering or others are offering. And being able to tie those together is a key direction that service operators need to look to go. And what they can provide is, first and foremost, the enablement, the ability to connect parties to each other in a cost-effective and unique differentiation. With that, they can layer in that experience that differentiates those services on behalf of their provider partners and or the users. Again, we see this today with such operators where they provide video across multiple devices, so users can take what they're doing in one location and take that with them across another device. And of course, they need to do this with economics in mind. The total cost of ownership of offering these new types of services, trying to drive the average revenue per user for that connectivity. So as we look for operators looking to differentiate, this application awareness becomes more critical. They look to, for example, in the healthcare industry, as I mentioned before, being able to enable healthcare providers to provide more in-home monitoring of their patients and their clients, so they can provide such things as daily weight tracking and medical usage, and providing a network that can a private network from the user out to that business that is aware of the applications that the hospital is providing to those users is critical for that. And with this, bringing in the experience, that personalization, again, service operators sit in a unique perspective or a unique area of understanding who the users are and where they're trying to go. They can really be a very critical tool for content providers in themselves to personalize content, provide the context of where the users are, what devices they're on and accessing from. But also as important is really that optimization, providing the best end-to-end experiences possible, and of course security and privacy are foremost. From the economic side, there's a number of content providers who don't want to have a direct billing relationship with users, but yet service operators have that. So there's opportunities to work with content providers at an application layer to provide rating and billing services on behalf of certain content providers, providing, again, security, traffic management, and policy management within there to help provide the best user experience from content provider out to user. And of course, enablement. And this gets into the ways of helping themselves be more application aware and helping connect the application level that users and businesses are looking for today, as that's where the business value is, back out with their customers and their subscribers, or back up to the services they're looking to achieve. And all of this, operators need to look at this in a holistic way in terms of trying to optimize their networks for the best user experience and for their customers' sake, providing their customers the best level of service and SLAs possible in a secure manner, because in today's world of IP connectivity and really application and web application type services, there's more and more vulnerabilities that are occurring at a higher level within the network. It's no longer just simple IP security threats or even lower. It's really application level threats and providing services to those folks that help protect at that application level. And finally, and critical as well, is how to extract the value out of their networks as these networks have to move up the OSI stack to layer 4 through 7 as well. So if we look at the application delivery attributes, there's a few things that really stand out. One is, of course, key to this, is having layer 4 through 7 awareness. Being able to understand what the applications are, what the services are that are running on your network. As voice, video, and data all coalesce onto the data side of the network, and with more and more of these new applications coming out above IP, having layer 4 through 7 awareness sits at the heart of really application delivery networking. And with that, it's being able to identify these new services, offer new application-based connectivity plans, and this really becomes key, again, as we see the machine-to-machine growth and businesses trying to connect with users in new ways upon which they want automated connected devices back in as part of their service. Again, this could be using the healthcare, for example, scales that automatically report weight back to their healthcare provider, or as we see more and more automobiles becoming connected, being able to provide differentiated services for those types of offerings for their corporate customers out to the users consuming those. Being able to have a flexible network that can adapt and optimize to this ever quickly changing environment that occurs at layer 4 through 7. And this is really to create the best user experience possible to their subscribers, not only for their own services, but the services that they're bringing to those users from third parties as well. And this can be a key differentiator. But as well, having an adaptable network that allows them to roll out new services in a quick manner, in a scalable fashion, and also in a flexible manner, as we see technology continuing over and over to proceed at a more rapid pace. Customer service, of course, is key. And then when we get to the cloudification, it's really that automating of operations, helping to control that bottom line in terms of trying to enable operators to do more with less and automating their networks and simplifying the rollout of these new services and having the context aware within their network to have their network adapt to the changing environments that may be occurring. Again, an example of that is some big event occurs in one area, allowing them to control their network to deal with a large increase of data traffic across that sector of their network and do it in a way that's fair to all users and provides prioritization for life services such as police and medical. So these are the key attributes that operators need to look at when looking in providing an application delivery network, and they move up that stack to the OSI model. At this point, I think we're going to pause for a poll. Jason?
Thank you, Sean. I'd like to launch a poll right now. You should be seeing it on your screen. What are the biggest challenges service providers are facing in the packet core right now? We'll allow everybody a couple of minutes. A lot of votes coming in. Got almost half of the audience submitting poll. We'll allow just a couple more seconds. We're at 70%. Get them in while you can. Five more seconds. And our results. Scalability to handle traffic growth coming in at 50% is the winner here. Coming up next, we've got network complexity at 38%, speed of deployments and time to market 28%, and constrained budgets at 24%.
Yeah, not surprising. In talking with a lot of customers around this, this question that I see from our perspective is definitely trying to handle that traffic growth is a key element. Now, with that, I think that it's interesting with network complexity being one of the big concerns as well. I think there's going to be a big debate within the industry coming up around how SDN and network function virtualization addresses that, and whether it truly does help simplify the network, or if it adds another layer of complexity. And I think that's yet to be seen. I could personally potentially argue both sides of that, just having spent a lot of time at F5 here and helping see customers implement virtualization into their data centers. From that standpoint, there's definitely some reduction in complexity, but of course, it also adds some as well. So yeah, I think this is in line with what I've seen. Thanks for the poll. We'll move on.
Thanks, Sean.
So now moving into what are some of the key components of an application delivery network. So as I've mentioned before, that the network has changed and evolved from the physical layer to the data link to the IP, and now we're up to layer 4 through 7. And another attribute that we have to acknowledge is with IPv6 as well, and just the general growth of traffic, and that points back to the biggest concern that a lot of people are mentioning here is the scaling of their networks. IPv6 is another key aspect that plays into this. And so when you move into layer 4 through 7, operators again are going to have to change the methodology at which they approach their networks, approach their operations, and look at the types of services and how they manage their network. When we hit there at layer 4 through 7, there's a couple key things that really increase in importance now for operators. First is DNS. application and service directory, essentially being able to provide an easy way for users to call out to access an application or service, but then translate that into the infrastructure, the underlying method of that managing it in the infrastructure, which is IP. So DNS is going to even just grow further into importance. We've seen this over the years as operators' networks have gone from having elements with a static IP to having a host name. And so when, for example, a serving gateway in a mobile network needs to connect to a packet gateway in that mobile network, it doesn't have statically defined connectivity anymore. It does a DNS lookup to resolve the names and get its preferential connected partner in a packet gateway. And DNS is at the heart of that. We also see that, as from a security perspective, for example, that as the applications and the traditional network threats have moved up, folks try to attack applications, and as security measures have been put there, we've seen security threats go against the DNS infrastructure now. So having a very robust DNS infrastructure is important, because the average person and consumer, they don't remember IP addresses, and so they remember URLs. And so if the URLs can't be resolved to the IP address, the application is essentially down as well. So this is an area of focus that service operators really need to go on and continue to invest in and view. With mobile networks, the whole network signaling is the next aspect that's key in an application delivery network. The network signaling is impacted dramatically by the applications running across an application delivery network. As we see new apps coming in where they're polling, checking for status, that has a huge impact on the signaling and connection management of users, especially with mobile devices. So being able to scale the signaling is important, and manage the signaling is very much important in an application aware network. Subscriber awareness is growing importance as well, as we see that subscribers want tailored and personalized services, being able to offer them new packages and understand what types of services are going, being able to have an element of being aware of your subscriber throughout your network is becoming important. And of course, talking about an application delivery network and not talking about application awareness would be a bit off. So having application awareness is really at the heart of an ADN. And this means, being able to characterize the different applications, understand not only the low layers, but even the higher layers, and being able to layer in services on top. Again, user experience, being able to help speed up through caching, compression is a key attribute. Being able to provide a better understanding at the connection layer of the application and how that operates. If we look at traditional traffic management solutions that would run in a network, people would operate at layer 3 at IP, and they may try to reroute something. When you move up in your application aware, you really have to have an understanding of TCP, because if you don't replay or switch the connection at the right point, that application can actually, from the user experience, actually go offline and cause that user to have to reconnect and restart their experience. So application awareness is not just being able to classify the traffic, whether it's web traffic or even Facebook or Google traffic or video traffic. It's actually being able to understand how those applications and the behavior of those applications run on your network. And again, in today's world, a lot of those run as a TCP. So having that TCP connection awareness and understanding is beginning to become more and more important to service operators. Just like it was for them to understand IP a decade ago, and they had to learn those skills, service operators are really going to have to start really understanding TCP, UDP, and the behaviors and how that impacts their services. Lastly, it's centralized policy management. I mean, this is at the, again, at the heart of what operators need to do as they move into an ADN is have that solution that allows them to define what they do on their network that matches to their business goals and drivers and their partnerships and broader ecosystem that they're providing. So having a way to manage policy centrally and then distribute that policy to intelligent devices out into the network to enforce that policy is all key to developing and delivering an application delivery network. So finally, when we look at what's going on, and some folks mentioned about complexity in the network, how does F5 look to address an application delivery network, and how do we look to solve some of this complexity? Well, when we look at a mobile network today, they're fairly static, and there's a lot of point solutions within a network. This includes, routers, packet gateways, firewalls, potentially DPIs, edge routers, so forth. These architectures are complex. They're hard to scale in the sense that you have to scale each one of these components in a different fashion. Typically, they come with their own, their separate vendors and or their own type of footprint. So sparing and operational costs become very costly or increased because you have to spare each one of these components differently. And so this is one of the drivers of why network function virtualization was introduced, is being able to start moving some of these components into commercial off-the-shelf hardware to help simplify and lower some of the costs as well. Now, as folks may know, virtualization, which really bore out of the server environment within the data center, has been really great for virtualizing high CPU and high memory intensive applications. Now that technology is continuing to mature. High network I/O type functions will get able to run more effectively on commercial off-the-shelf hardware as well in a virtualized environment. But today, there's still a couple of challenges there. But how can operators look to simplify their network while introducing the layer 4 through 7 intelligence they need to deliver an application delivery network? At F5, we view it first and foremost on the data plane side as being able to consolidate services. So not so much into a single device per se, depending on the size of the network, that's a possibility, but consolidating of some of these data plane functions such as policy enforcement, firewalling, carrier grade netting into a standardized platform that is software enabled. So it can simplify sparing costs. When you have a single platform that enables new services via software, those services, those elements can be deployed in a single device or spread out across multiple devices, and those services shifted via just software. Now, of course, if the needs are to move on to COTS hardware, you can also provide these same services software only as virtual machines, virtual devices and appliances within the data plane as that technology matures. We have it today. As we see it maturing in the future and the performance continues to improve and the capabilities, it's a very viable option for operators to help simplify their data path while also introducing that layer 4 through 7 intelligence and that application awareness and programmability that you'd want in an application-defined network. Next, of course, is signaling. As mentioned before, signaling is becoming a more and more critical part to an application-based network where applications create multiple signaling events in terms of their updates and being aware of that. And having a scalable solution within the network that provides that that diameter signaling in the 4G environment becomes critical. Again, whether it's a physical or a software device that fits into NFV, that's the operator's choice. The other critical component is DNS. As mentioned before, DNS in this application world takes on even more of a role as the service directory, not only for the operators, but for their other solutions and services. And as mentioned by the first poll, the scalability to handle traffic growth is a big concern. And so having a DNS infrastructure that can scale with the millions of queries per second that occur and will occur on the network as new services are introduced by the operator, as they're providing value-added services to over the top, and really with the growth of machine-to-machine connectivity as that goes, and operators help enable that, being able to have a scalable solution for domain name service and DNS is critical. If the operator's DNS service goes off, for all those users that they maintain and have on their network, essentially the internet goes off or their business goes offline. So DNS takes on a new critical realm with an ADN. And next, it's really helping to enable that infrastructure of a cloud-enabled value-added services that the operator may look to drive and offer. And this is where, when you look at the trend with network function virtualization, is a great area for operators to look to help reduce their network infrastructure costs and introduce that virtualization, providing agility into their network, along with the cost savings of commercial off-the-shelf hardware. And orchestration is a part of that. And that not only includes orchestration from the virtual machine side, but having the intelligence within the network that's application aware with devices that are programmable. So you can tie this together so you can automate as much of these services as possible. And I have an example coming up here shortly on how one avenue where F5 can help enable operators to introduce that. And finally on this, it's software-defined networking, and how does that play with the open flow type environments and the underlying layer 2 through 3 infrastructure that acts as the transport for this new network that's application aware, and making sure you can tie in the elements in your network that are application aware down to that transport infrastructure, and do that in a scalable and manageable fashion. So the one example I want to provide, and we have this available on our website, is with network function virtualization and application awareness, what can be done today, and what are operators, and how can operators benefit from having an application delivery network. This example is just a screenshot. What it shows, though, is by having application awareness within the network, you have that capability to understand what users and services are going to which services and the state of those services. It's not just a simple ICMP check of whether that service is aware. It's what load is that service going on. And in this case, what we have is we have users who are accessing video out on the internet. Some of that video can be optimized. Some of that can't be, just by the nature of the type of video being accessed. The big IP is aware of those different types of video formats, and working with partners can steer the video that can be optimized into a video optimization system. Now, that video optimization system in this demo is running as a virtual machine on COTS hardware that's been virtualized within this network. As we're steering that video into these optimization systems, we also are monitoring the health of those systems and the load of those systems. As the load increases, as that video became more popular and more users were accessing it, we determined that system was reaching its limits. So we called out to an orchestration engine through a programmable interface on our own device and through the orchestration engine to add additional service capacity. So it spun up essentially additional video optimization instances. We're able to add that into our awareness and steer the additional traffic into the additional instances of the video optimization system. So what this demonstrates is having an application-aware network allows you to scale on demand, control your network infrastructure, but yet not have and control costs, so you don't have to provision every service for 100% peak load and then some. It allows you to share a common infrastructure as different services become popular than other ones. You can add and remove capacity all on the fly without operator intervention. So it's looking to address not only the operational and network costs that operators are facing today, it also can help introduce more agility into the network while also providing a differentiated application-aware service that the operator can provide into their users. So preferred users can get optimized video or whatever their business policy may dictate for that. So this is one way that application-aware and the cloudification of an SP network come together. And with this, that really hits at the heart of the network function virtualization effort that operators are going through today. So a different representation of this, again, is when you introduce application awareness into your network and you cloudify your infrastructure as well, you can have your network achieve a level of dynamic capability that isn't available in today's networks. And so in this case, as users accessing certain applications increase, again, you call out to an orchestration engine to spin up additional instances of those applications, and or have the awareness that if in one data center you've reached capacity, you can send the overload users to another data center within a cloud network. Again, all application-based and leveraging the latest capabilities. So at this point, we're going to stop and take another poll. Jason?
Thanks, Sean. I just launched our poll on the screen. What are the biggest factors for service providers driving the merger of SP and IT networks? I'll leave this up for about a minute or two while folks can vote. The need for billing and policy integration, data center consolidation, traffic and subscriber analytics and big data, and cross-vendor service orchestration, SDN and NFV, just like you mentioned. We'll wait about 30 more seconds. A lot of votes coming in now, Sean.
All right, thanks.
Give everybody about 10 more seconds. And this is just a reminder, if you submit questions, we will address them in our Q&A at the end of the broadcast. All right, looks like the votes are coming in, and I'm going to share the results now. All right, we've got two in the lead here, Sean: traffic subscriber analytics and big data, and cross-vendor service orchestration.
Yep, not surprising again. You know, I think both of those are very interesting areas. With, you know, I think traffic and subscriber analytics, big data. I would argue, and I'd definitely be interested to hear from any of the listeners out there. I think that's probably the more mature and near-term type capabilities that are available, and, you know, as the question asked, are part of that merging of IT. And, you know, I think what we see, you know, I see it, is operators are tooling their networks more and more to collect more data to understand their networks, so forth. And by having application awareness into the network, that can provide them that additional level of visibility to really better understand the services they need to offer and what their subscribers and their network is doing in order to best optimize their network. The the next one that came in, the cross-vendor service orchestration, is, I think, a really interesting one. Again, as I spent the last few areas talking about that, I think that one's longer term. And again, for any of the operator listeners out there, I definitely love to hear your opinions. But mainly because, while technology has been proven within the data center to essentially do this today, and there's a number of large enterprises, government entities, and even service providers in their data centers who have created such a dynamic data center for service orchestration and on-demand, service instantiation. I think the movement of that into the core network, while we're a believer in it occurring at F5, I think there's some bigger challenges that are going to be an interesting dynamic in it, and that's namely organizational. I think there may be an organizational challenge where operators just, I'll go back to that first slide that I put up where, when operators are moving from fixed line into ATM, you had the circuit switch folks, talking about this newfangled capability of frame relay or ATM, and they couldn't get their head around it. And of course, new skill sets had to be brought in, and as they adapted to that, then the next thing was IP. And all the ATM frame relay folks had to learn this new technology and wasn't unsure. The same challenges I could see occurring with this IT and SP networks converging, where you have siloed services within the core network that now have to be broken up because you want to leverage a common set of infrastructure and allow those services to run on top. And then, so not only organizationally within the operator, what does that mean? But then what does that mean for the vendors that are supplying into that, where historically you may take, and I'll just pick on the video optimization solutions again. You typically acquire one of those from a vendor and they bring top to bottom, and now they supply the servers that their software ran on, but now you're asking them to only provide that software. And so where do those demarcations reside? So I think that cross-vendor orchestration and the SDN NSV stuff is a big driver for that work, but I think it's also one that there's a lot of non-technical challenges that we'll need to work through. So it's interesting to see the result. So I appreciate everybody taking the time on the polls, and definitely we'll have time for questions here in just a minute. But what I just wanted to close out with is to summarize, our view here, F5, around application delivery networks, and for operators, the considerations they need to take away. Operators, fact is, they need to shift away from providing only connectivity to providing a compelling user experience. They need to move up and understand the application layer. They need to understand TCP, moving up into sessions, and the actual protocols that are running on top, and offer a very compelling experience to their users. And when I say users, it's not only the consumer side, but also the enterprises and businesses upon which they're providing services to as well. The network value has shifted from layer 3 up to layer 4 through 7, the application layers. This is the operators saw the value of having a common network infrastructure based on IP, and now that it's just expected that users will connect to the internet and have IP connectivity, that differentiation is gone, and so that next shift in operators' networks needs to occur, and it's starting to occur today with the move to layer 4 through 7. These networks, as mentioned, really they need to be policy aware. That's going to drive this next generation of network, is being able to translate a business policy, a subscriber policy, a policy into the actions within the network. So being policy aware, being service or application aware, and really having an infrastructure that's adaptable to the changing landscape, because the landscapes are changing faster and faster as technology continues to grow and mature. And finally, the network really needs to move from a static infrastructure into a flexible software-based infrastructure that can be programmed, not only from the need of being able to help reduce operational and CapEx costs, but really to help improve the agility for operators to address the elements above in terms of the changing landscape of services, service offerings, and what their subscribers are doing in the device proliferation as well. So that concludes our webinar for today. At this point, we will be open to taking some questions for the next few minutes. I would like to thank everybody for your time and listening, and if there's any questions, please feel free to submit them in through the online portal.
Thanks, Sean, and I've got a couple of questions from the audience right now. Let's begin with, why do I need L47 visibility in the network?
Sure. So as mentioned, the layer 4 through 7 visibility is really where the services are going now for operators. With voice over IP becoming dominant, with over-the-top type voice services, video is all running over IP now. Having that understanding of what's going on at your network above layer 3 just really is becoming fundamental for operators.
Thanks, Sean. I've got another one here. Won't consolidating network functions introduce more possibility of single point of failure?
That is a possibility. When you look at consolidating a bunch of devices or a bunch of functions into a single device, what I would say to that one is you're not so much consolidating functions into a single device as much as you're consolidating functions into a single platform, meaning that platform, it's a single kind of code base upon which you can enable these functions in different footprints. So the value proposition there is that if you standardize on a certain type of hardware, that could be F5 hardware for some of these functions, or it could be commercial off-the-shelf hardware as well. The point is as an operator, by having these functions be software enabled, that allows you to shift those functions to the best platform, physical platform that meets your needs. In today's world, having special purpose hardware still gives you the best price per performance you can get. I mean, that's why you won't see core routers going on to a blade server at this point. There's the price per performance and the robustness is still there on special purpose hardware. But at the same time, some of those functions may be ready for commercial off-the-shelf hardware, and you can move those. The point being is you have these functions that are software enabled, have programmatic interfaces, so you can tie them in to your orchestration and network infrastructure in a common manner, regardless of where they sit. So when we talk about consolidation, we really talk about consolidation of functions onto a common kind of like OS or platform, not necessarily the physical platform itself.
Great answer, Sean. This question coming in from Steve.